We're looking at the equation y prime plus x times e to the y is equal to 0. And we're going to solve this in a few easy steps. There's going to be a little bit of a trick towards the end, however, to solve for y itself. First thing that we do when we have a differential equation like this is we notice our y prime here. We want to replace that with a dy over dx. So we'll start off with dy over dx plus x e to the y is equal to 0. Next up, what we want to do is we want to separate our x's and our y's. So let's start off by moving half of our information over to the other side of our equation. So we're going to subtract x to the times e to the y. And now what we're going to do, we're going to do two things here. We want to move our dx over to the right-hand side. I'll do this in two separate steps here. So we get dy is equal to negative x e to the y dx. And the next thing we are going to do is you notice that we have a y stuck to this e. We are going to move this over to the left-hand side. So in this case, we'll have to divide e to the y. dy is equal to negative x dx. And I'm going to rewrite this one last time. And one thing to notice is when we are looking at 1 over e to the y, we can rewrite that as e to the negative y. So remember, our exponents become negative if we throw them up in the numerator. This is going to make our lives a little bit easier when we integrate. So let's rewrite it one last time. dy is equal to negative x dx. And now we have it set up. X's are all on the right-hand side. Y's are on the left-hand side, which means we are ready to integrate. So we just want to stick that integration symbol out front. And next thing we are going to do is actually integrate. So antiderivative of e to the negative y is going to be e to the negative y. Throw a negative sign out front. If you have questions about that, notice that it's actually a u substitution that we're working with there with a u is equal to negative y. So that's how our negative sign comes out in the front here. And on the other side of our equation, we add 1 to our exponent, divide by our new exponent. And because we are working with indefinite integrals, there are no bounds on there, we're going to add a constant onto the back side. You only have to do this to one side of your equation. You don't have to do it to both. We are going to solve this equation for y. So what we want to do is we want to isolate this y by itself, which means we have to get everything else to the other side. Let's start with throwing that negative sign over to the right-hand side. If we multiply both sides by a negative 1, we are going to get rid of that negative sign in front of the x squared over 2. And we're going to I'm going to modify a little bit because I don't want to write x squared over 2 minus c so much. I'm just going to change that into a plus, and I'm just going to call our new constant c1. It's neither here nor there. If you want to keep it as minus c, that's perfectly fine. It's the same thing. So now we have e to the negative y is equal to x squared over 2 plus c1. Here's where things get a little bit dicey. We want to get rid of this e value here. And to do that, we are going to use our handy-dandy natural log. When we take the natural log of one side of our equation, because there's an equal sign there, we need to do natural log of the other side of our equation as well. So now we have natural log of e to the negative y is equal to natural log of x squared over 2 plus c1. All of that is in print or in absolute values. Notice our natural log and e, they are opposite functions. They're going to cancel each other out. And we're left with a negative y is equal to natural log of x squared over 2 plus c1. One last thing, move our negative sign over to the other side. And we end up with y is equal to negative natural log absolute value x squared over 2 plus c1. And there is our solution for our differential equation. Thanks for listening.